This lecture is going to cover stoichiometry. Now, when you look at this word and when you hear this word, it sounds pretty intimidating and sounds pretty complicated, but really it's simply converting. So we'll go through it, we'll get a definition, and it's not as bad as what it sounds. Before you get started, please make sure you have a periodic table, make sure you have your calculator, and you also need that objective sheet so you can make sure you know what it is that you need to be able to do by the end of this lecture and the practice problems. So what we're doing is we're converting with chemical equations. So stoichiometry, here's your definition. We're going to use relationships that are known in a chemical equation to determine unknown quantities. So in any equation, we're going to know some things about the equation. And what we're going to use is the stuff that we know to determine what we do not know. So you've probably done some things in math before when you have some knowns in a problem and you have something unknown. Same concept, same idea here. So there are some things that you need to be proficient in, and this is one reason why we've done these things prior to this unit. The first one is balancing equations. You have to have balanced equations, or you are going to get wrong answers every single time. So all that stuff with balancing equations, it's not going away. It's very important in this section. The second is conversion factors. So using things like going from grams to moles, moles back to grams. Very important that you're able to find the molar mass of a compound. Going to use this throughout this entire unit here. And the last thing is using and keeping track of correct units. So you saw this a little bit before when you were converting from grams to moles and moles to molecules, but it really goes back to the root of everything we did in the very beginning of the year with dimensional analysis. You have to know what units you're using, you have to know what you're starting with, where you're going to, what units are canceling, and being able to use those conversion factors. So this unit, this with stoichiometry, is really going to start to pull everything together from out the whole year. All right, so we have this thing called a mole ratio. So what it's going to do is show us the relationship of moles between two different substances. So up to this point, all we've been looking at is the relationship between one substance. How many moles of one substance is how many grams of that same substance. We've been looking at the same thing. So if I have 2 moles of oxygen, how many grams is that? But now we're going to be comparing oxygen to carbon, or hydrogen to sulfur, or nitrous acid to nitrogen. We're going to be comparing two different things. So it's going to allow us to convert. So it's going to show a relationship, but then after it shows us that relationship, then it will allow us to convert from one unit to another. And remember that this is going to be different than what you've done before, because like I said, when we were using the molar mass previously, that allows you to convert within the same substance. So this key here, and I've said it so many times already on this slide, is different substances. So this is going to take us a step further than what we've done already. All right, so we have potassium plus chloride is going to give us potassium chloride. So first thing was to balance this equation. So I've already balanced this for you, but make sure that you are confident in how to balance equations. Remember that this chlorine here is a Humphrey, that's why there's 2 on that subscript. So now we're going to write mole ratios. This is the number of moles of one substance to the number of moles in another. So remember, a ratio is just a comparison. I have this much of this for as many of these as I have, okay? So one of the first ratios we can look at is we have 2 moles of potassium. So I got the 2 from that coefficient out front. So for every 2 moles of potassium, I'm going to have 1 mole of Cl2, because really I could have a 1 right out in front of there. Remember, no coefficient means 1. So this right here is a mole ratio. 2 moles of potassium to 1 mole of chlorine. So another example of what we could get from this problem would be for 2 moles of potassium, we also have 2 moles of potassium chloride. That's another ratio. And then the last one could be comparing the chlorine to the potassium chloride. 1 mole of chlorine, 2 moles of potassium chloride. There's my third ratio that I can get from that equation. Now the important thing to note about this is you could write it like this. 2 moles of KCl, 1 mole of Cl2. These are the same thing, okay? It just depends what unit you need to be on the bottom, what unit you need to be on the top in order for units to cancel, so we'll practice that in a little bit. But just know that that is the same thing. It's just a reciprocal of what you wrote before. But you can write it either way, whichever way you need it. All right, so a mole-to-mole equation, or a mole-to-mole problem. This is an example of a type of problem that you could see. You have nitride and hydrogen gas react to give ammonia. How many moles of ammonia will be produced from 2 moles of nitride? So now we have to remember what all these things are. We have to write an equation first. So remember that nitride is going to be N2. Hydrogen gas is H2. And then you don't know this, but ammonia is NH3. So we're going to write that equation. N2 plus H2 gives me NH3. Now, we have to remember that this equation needs to be balanced. So if I put a 2 here, a 3 here, that should be balanced. 2 nitrogens, 2 nitrogens, 6 hydrogens, 6 hydrogens. So here's my balanced equation. Step 1, make sure that's complete. Now the next step is to look back at the problem. I want to know how many moles of ammonia will be produced from 2 moles of nitride. So I need to write out my mole ratio first. My moles, I'm going between ammonia and nitride. So for every 2 moles of NH3, I have 1 mole of N2. Now, it is very, very important that you are including this in your units, and you'll see that in the next problem. Actually, you'll see a little bit of it in this problem. So I said before, when you were working on molar mass, include the name of the formula or the compound you're looking at. It's going to become a habit that you're going to be thankful for in the future. So here's my mole ratio. I have to use this to determine how many moles of ammonia I will get from 2 moles of nitride. So this is just like a dimensional analysis problem where you start with what you have, what you know. I know I have 2 moles of nitride. So I have 2 moles of N2. Now to get moles of N2 to cancel, I'm going to take this mole ratio right here, and actually the way I set it up is perfect because I'm going to have 1 mole of N2 and 2 moles of NH3. Now, moles of N2 cancel, and I'm left with the unit of moles of NH3, and now I just do my math. So if I multiply and divide, I'm left with 4 moles of NH3. Okay, so that's going from moles of one substance to moles of another. So So now we're going to make it a little harder. We're going to go from moles of one substance to mass or grams of another. Potassium chlorate decomposes into potassium chloride and oxygen. 1.5 moles of potassium chlorate decomposes. How many grams of oxygen will be produced? So first thing we have to do is write out our equation. So go ahead, pause this. I want you to write out a balanced equation on your own. Come back and double check. You can never get enough practice doing this. So pause it, write your own, come back and check. Okay, so here's what you should have for your equation. Now let's look at our problem. Our problem wants to know, we have 1.5 moles of potassium chlorate. How many grams of oxygen will be produced? So we need to find a mole ratio between potassium chlorate and oxygen. So here's my potassium chlorate, here's my oxygen. So that's 2 moles of KClO3, 3 moles of O2. So remember this ratio. And remember, it can also be flipped depending on what we need here. All right, so let's flip to the next page. So here's our equation again. Remember that we have 1.5 moles of KClO3, and we want grams of O2. So start with what you know. What do we know? We know that we have 1.5 moles of KClO3. Now I have to use that mole ratio that we wrote on the last slide. To get moles of KClO3 to cancel, it needs to be on the bottom. Two moles of KClO3 for 1 mole. Oh, that is not correct. 3 moles of O2. Check your units. What cancels? Moles of KClO3 cancel. So if I were to stop here, I would be left with what? I would be left with moles of oxygen. But I don't want to be left with moles of oxygen. I want to be left with grams of oxygen. So now I have to keep going. How do I go from moles of oxygen to grams of oxygen? We've done this already. 1 mole of O2 is 32 grams. So that just goes back to your molar mass. Nothing new there, okay? Remember that it's O2 and not O, that's why it's 32 and not 16. Check your units, see what cancels. Moles of O2, moles of O2. I'm left with grams of O2, which is what I wanted. All right, go ahead and do the math. I want you to pause first before you check to see if you got the same answer as me. Go ahead and do your math, and we'll come back. All right, so here's your answer. You should have been left with 72 grams of O2. If you did not, make sure that you did divide by 2. That could have been one of the problems here. So 1.5 times 3 divide by 2 times 32 will give you 72 grams. All right, last type of problem you could see is going from mass to mass. So we've seen going from mole to mole. We've seen going from mole to mass. You also, just like the last problem, I could give you mass and you go to moles. That's the same problems, just reversed. And now we're going from mass to mass. So this is going to be the longest problem that you will see, but it's incorporating all of the things that we've done so far. So no new steps, just extra steps. So gold 3 chloride is going to decompose into gold and chlorine. How many grams of chlorine will come from the decomposition of 64 grams of gold 3 chloride? So step 1, always write out your balanced equation. Go ahead and pause it, write out a balanced equation, come back and check your answer. All right, here is your balanced equation. Make sure we're on the same page. We have 2 golds and 6 chlorines on each side of the equation. Remember, chlorine's one of those Humphricals. Need 2 of them. All right, so here's the equation again, just so we can see it. Now, if you go back, I'll go back to here. We're looking for grams of chlorine that come from 64 grams of gold 3 chloride. So we'll write out our ratio first. So 3 moles of Cl2 for 2 moles of AuCl3. That's our mole ratio. And we're starting out with 64.0 grams of AuCl3. So we cannot directly go from grams to grams. We have to go from grams to moles and then back to grams. So I'm going to start out with the 64 grams of gold 3 chloride that I have. And what I need to do is go from grams to moles. So your molar mass, I'm just going to tell you what this is, but your molar mass of gold 3 chloride is 303.32 grams of AuCl3. Make sure you're always writing those units out, okay? And that's for 1 mole of AuCl3. Okay, so now my units of grams per AuCl3 are going to cancel. Now I'm going to be left with moles. So now I have to go my mole ratio between my gold and my chlorine because I'm trying to get to chlorine. So my mole ratio was 2 moles. Remember that AuCl3 has to be on the bottom because it's on the top right here. And 3 moles of Cl2. What units cancel? Moles of AuCl3. See why it's very important that you write out your units, because if not, we could have easily switched this and just canceled out moles, but not known that it was the moles of the gold. Now I'm in moles of chlorine. Go from moles of chlorine to grams of chlorine. 1 mole of Cl2 is 70.91. Remember that I have 2 of them, so don't use just the 35. Moles cancel, moles cancel. I'm left with grams of chlorine, which is what I'm looking for. So it's very, very important that you make your units cancel. Now, go ahead and pause this, do the math, come back, and we'll see if we have the same answer. All right, so you should have got 22.4 grams of Cl2. If you did not, it's very important that in this mole ratio, you are using both of these numbers. A lot of the time we're used to one of those numbers being 1, so we don't do anything with it because multiplying and dividing by 1 is going to give us that same answer. So make sure that you're multiplying by 3 and dividing by 2 if you did not get the right answer. If you did not, go back and try and see if that's what you missed. If you did not get these answers, come see me because there's something wrong with the way you're typing it in the calculator or you don't have something set up correctly. All right, last thing. Things to think about when you're approaching the problem. The first thing is, what am I given? Am I starting with the moles? Am I starting with mass? What am I given as my starting point in the problem? The second is, what am I going to? Am I going from moles to moles, or am I going from moles to mass? Am I going from mass to mass? You need to know what you're starting with and where you are headed, so you know what steps you need to take. The next thing, is my equation balanced? So hopefully you see, after doing this, that your equation needs to be balanced for you to get the correct answers, because that balanced equation is going to lead to a correct mole ratio. And you can see that if your mole ratio is not correct, it's going to give you the wrong values to plug into that dimensional analysis equation. So we have to make sure our equations are balanced. And then, do my units cancel? So make sure that you include your compound in your units. So don't just leave it as moles. I want it to be moles of Cl2. Grams shouldn't be left just as grams. It should be grams of O2. Okay, it's going to help. It makes it so you are able to double check that your units cancel, and it also ensures that you're setting your problems up correctly. You don't want to divide when you should be multiplying, and that's what the problem will occur. So go ahead, work through some practice problems. Let me know if you need any help. Good luck.